Welcome back to our electrical engineering series. In our last lesson, we covered essential electrical components and their symbols. Today, we'll dive into basic circuit analysis, including series and parallel circuits and Kirchhoff's laws. I'm Uthman Nefali, and let's get started. First, let's look at series circuits. In a series circuit, components are connected end to end, so there's only one path for current to flow. In this series circuit, the same current flows through each resistor. The total resistance, R total, is the sum of the individual resistances. R total equals R1 plus R2. The total voltage, V total, is the sum of the voltages across each resistor. V total equals V1 plus V2. Let's say we have a 12-volt battery and two resistors, 4 ohms and 6 ohms. The total resistance is 4 ohms plus 6 ohms equals 10 ohms. Using Ohm's law, I equals V over R, the current. I is 12 volts over 10 ohms equals 1.2 amps. The voltage drop across each resistor is V equals I times R. For the 4 ohm resistor, V1 equals 1.2 amps times 4 ohms equals 4.8 volts. For the 6 ohm resistor, V2 equals 1.2 amps times 6 ohms equals 7.2 volts. Adding these gives us the total voltage, 4.8 volts plus 7.2 volts equals 12 volts, which matches our battery voltage. Next, let's explore parallel circuits. In a parallel circuit, components are connected across common points, providing multiple paths for current to flow. In this parallel circuit, the voltage across each resistor is the same. V total equals V1 equals V2. The total current I total is the sum of the currents through each resistor. I total equals I1 plus I2. The total resistance is found using the formula 1 over R total equals 1 over R, 1 plus 1 over R2. Let's say we have a 12-volt battery and two resistors, 4 ohms and 6 ohms. The voltage across each resistor is 12 volts. Using Ohm's law, the current through the 4 ohm resistor is I1 equals 12 volts over 4 ohms equals 3 amps. And the current through the 6 ohm resistor is I2 equals 12 volts over 6 ohms equals 2 amps. The total current is 3 amps plus 2 amps equals 5 amps. To find the total resistance, we use 1 over R total equals 1 over 4 ohms plus 1 over 6 ohms equals 3 over 12 plus 2 over 12 equals 5 over 12. So R total equals 12 over 5 ohms equals 2.4 ohms. Now let's move on to Kirchhoff's laws, which are essential for analysing more complex circuits. Kirchhoff's current law, or KCL, states that the total current entering a junction must equal the total current leaving the junction. For example, if I1 and I2 are entering the junction and I3 is leaving, Kirchhoff's current law tells us that I1 plus I2 equals I3. Kirchhoff's voltage law, or KVL, states that the sum of all voltages around a closed loop must equal 0. In this loop, if we have a voltage source V and two voltage drops, V1 and V2, across the resistors, Kirchhoff's voltage law tells us that V minus V, 1 minus V2 equals 0. These laws are incredibly useful for analysing circuits where components are connected in complex ways. We'll use them frequently in our analyses. In the next lesson, we'll explore AC versus DC circuits, looking at their differences and applications. Make sure to subscribe and click the bell icon to get notified when the next lesson is out. Thanks for watching.